Okay. All right, let's start it now. Let me share my screen again. Right, so here is the easy problem for today. Are you guys able to see the screen? Just to confirm.
Yes.
Okay. So we have to write an algorithm to find if a number is happy. So what happy means is if starting from the number, and if I square each digit of the number and sum it up and keep doing this process again and again till we find a sum which is equal to 1. If we are able to reach to this state, that means the number from which we started is a happy number, else it is not. So anyone tried or have an approach for this? Anyone? Any ideas?
I have one, but I will wait for others to reply. Maybe.
I
I have solved this question.
Mm-hmm.
So it seems like what I did is basically started a loop until or unless I reached 1, and I started with the number which is given. I squared it, and whatever the number I get, I am putting in a set until I'm putting in a set like if that number is not seen before, like. So, like if 82 occurs before also, then it means that we have a cycle and we never reach to 1. We never reach to 1. So that's why we need a set for that.
Mm-hmm.
And like this, I am finding the square of all these, the numbers which I am getting until unless I reached 1. Or if I reached, either I reached to 1 or I reached to the number which was already in a set. So that would be the return conditions for me.
What would be the time and space complexity for this approach?
So it will be like I'm not sure about, because we are not sure how many numbers will be there. So
like it will definitely not be a constant space.
Yeah.
Right. And from time complexity point of view?
It's keep on going until or unless, like my loop is going until or unless I reach to 1 or the same number which I have seen before. So,
right. So it's a bit of, dicey to decide the time complexity in this unless and until you know the mathematics behind these numbers.
Yes, actually.
Even I don't know the number, but I was just thinking, because this is the question that came in mind, what is the time complexity for this? It's definitely not constant. I don't know if it's linear or it's square. Roger, you have any idea about the time complexity?
No, actually, I had the similar questions. Should I spend some time? But yeah, for now, I have the same answer. It depends on the number, and unless we go start plotting, especially the worst case, what can have, I don't know.
Right, it's kind of it's a bit difficult. Okay, so yeah, the approach which was just discussed, like, you keep on doing what is asked and keep doing it till you either find 1 or one of the elements which is already calculated, right? So any other approach, if we can reduce the space complexity at least.
So this problem also reminded me of the loop in a linked list.
Right.
And that was solved using fast pointer and slow pointer. And I actually I looked at the linked list solution, and then I could solve for this problem as well.
Right, cool. Could you share what you have done from the 2-pointer?
Let me share my screen.
Let me stop.
happy number solutions. Okay, the 2-pointer one, I have actually solved it in a fair book. The one that I submitted is the set one. I can share the solution later in the playground if that's okay.
Yeah, that's okay. If you could just explain what you have done.
Yes.
If you could relate it to linked list and what you have done for that.
Sure. So basically what happens is you iterate one, let's say you found a number, let's take 153 as an example. 153 will give you a sum, let's say 81. And then after some time, you see that the numbers start repeating. So that means there is a, okay. So what you do is you start your slow pointer at the beginning of this thread or beginning of the your fast pointer will be the next one in the line. So your slow pointer is going one at a time, whereas your fast pointer is going to skip one. So it's going to be alternate position. Does that make sense? Hello?
It's not clear. Probably I can show them out. Like,
yeah,
if
sure.
you have anything like a linked list, let's assume it's a linked list for now. And at some point in time, you have a loop. Right? And suppose this is again getting back to this one.
Yeah.
Now, what will happen is what Smita was mentioning was you have a fast pointer and a slow pointer. Slow pointer will take one step at a time and fast pointer will take double the steps. At some point in time, both of them will be a part of this loop, right? So suppose fast pointer is here and suppose slow pointer is here. Right? Now, if you keep doing, keep running the loop inside slow pointer by 1, fast pointer by 2, at some point they are bound to intersect. Right? So she's using the same logic in this numbers. Like suppose we are generating 88, and then after that, based on this, a number is getting generated, which is suppose 91, and then based on this, there's a number generated 22. And if suppose at some point in time we get a number back, right? And based on this analogy, same analogy, if we have a fast pointer, which is essentially calculating 2 steps in advance, and there's a slow pointer which is calculating 1 step in advance. If you keep doing this, at one point you will find fast and slow pointer intersecting with each other. And if this happens, that means the number cannot be a happy number. There are only 2 conditions to end this. One is either you reach 1 or your fast pointer and slow pointer become same. Right? I hope this is clear now.
Yes.
Any other questions, any other approaches? Anything, any other approach anyone tried or any other ideas?
So I have a doubt. So how will create a linked list of this?
So you don't have to create a linked list in data structure, but a logical linked list in IDEA. So if you if you are taking this thing only, this is your actual linked list. But in case of your numbers, it's just a logical linked list. Like you use this number. Let's suppose you have 88, and you create a next number which is 64 plus 64, right? Which is 128. So essentially, this is kind of a linked list where this number is generating the next number, and then next number can be 1 square plus 2 square plus 8 square.
So like this, we are storing somewhere. So it's like we need a set for that, is it?
No, we don't need to store anything. So essentially, so at any point in time, we just need 2, S and F. right? Because S will itself create its next S and F will automatically create its next F. As we are saying, at some point in time, these two will be same, right?
So actually think it like this.
Okay, got
Like,
it, got it.
okay, so got it. Let me complete just one liner. How I would look at it, that your starting point is whatever the number was given. All the rows are representing the function you are running on that, and that function is like you square for each bit, and you result in another bit. So that is your next step. As a graph, you can think it again. Linked list is a special kind of graph, so let's call it linked list. Now, like we are applying the exact same principle, that in this particular case, you will call the function 2 times in case of fast pointer. And you can apply this method in any function which is deterministic. Like if your function doesn't change, like, randomly, then the same method could be applied on any problem. We can probably apply it on the next problem as you will see most likely. So that's it. Like, if any questions, you can ask if there is any doubt.
Yeah, any other questions? I think someone had some idea, trying to say something.
So
If
could it
not,
be like there could be multiple paths to come back to the same node? And in that case,
we're saying multiple paths to come back to same node, let's say
Yeah.
64, right?
right.
It can be 64 plus 64, b square plus b square. I don't know.
I'm not sure if that that's really the case, but just imagine that there could be multiple paths going back to the same node. Would that affect the runtime complexity? Because if we see the set, if we have a set, we will recognize, okay, we already see this number before.
No, sir.
First time.
Go ahead.
I was just going to say the first time you see the value in the set, or the first time you see the value in the cycle, it's going to be the same, right? Because suppose you have reached here with set approach, you might have also reached there with the slow approach, slow pointer approach, or fast pointer approach, right? And the next step with the fast pointer will, slow pointer will again be the same. The maximum which I can think it can skip by is one cycle. Yeah, right. So if you say time complexity, it may skip by one full cycle.
Yeah, that's right.
Yeah, and that depends on the length of the cycle.
Right. Roger, any take on that?
So the question is what, like, how the time complexity is affected by this approach?
Yes. So the thing is, can a number, suppose we are able to calculate this from 88, and it gives rise to, suppose, 128. Can this number be reached from multiple nodes? So destination of multiple numbers, can this be the destination? So if we say the equation a square plus b square equal to c. So can we have two multiple values which can, or pair of a and b, which can give rise to the same c?
It is possible to reach, like,
Yeah,
but the thing is, once you reach there, our function is not returning a different value each time, right? So you have a defined cycle size. It's not growing or anything, so it won't affect your complexity a lot. I mean, you can detect, as you already said, using set a bit faster, but time complexity wise, it doesn't affect the time complexity, because once you have a fixed set of your cycle size, it is okay. Like, you will spend one extra cycle to confirm that, yeah, we have found the place where we are actually catching it.
To answer your question, it may be a trade-off between space and time. If you want to use up the space and get it done a cycle faster, or you want to not use the space and take one more cycle, or at a max one more cycle to get the answer.
True.
Should we move ahead to the next question?
Yes.